AI isn't necessarily coming for your job today, but it is, very quietly, silently, locking the door behind you.
Yeah, that's exactly what's happening.
Welcome to the Bite-Sized Tech News TLDR. I'm glad you're joining us because today's deep dive is all about establishing the absolute bottom line of a massive, truly massive structural shift happening in the economy right now.
And we are doing it with zero conversational fluff today.
Exactly. We are pulling directly from a groundbreaking March 2026 economic report from Anthropic. It's titled Labor Market Impacts of AI, a New Measure and Early Evidence. And our mission for you today is to cut through the theoretical panic. We want to look at the raw telemetry of what is actually happening inside the enterprise.
Right, getting past the hype.
So we're going to cover exactly which jobs are at risk, how you can adapt, 3 concrete ways to use AI for immediate productivity right now, and what the real labor market data actually says about layoffs versus long-term growth. Okay, let's unpack this. We need to transition away from the theoretical hype and look at the enterprise reality.
Yeah, the context here is just critical. Because for the last 3 years, the labor market has been operating under a deeply flawed set of assumptions about how automation actually deploys.
We've been living in this science fiction narrative, right?
Exactly. Yeah. We've been heavily influenced by some rather panicky theoretical models from the early 2020s. But this specific Anthropic report changes the paradigm. It brings hard, empirical, real-world telemetry to the discussion.
Which is so refreshing.
It really is. It shifts the conversation from what AI is intellectually capable of doing to what corporate America is actually allowing it to do on a Tuesday afternoon.
Let's start right there with the core metric introduced in this report, because it completely redefines the timeline of this technological shift.
Yeah.
The metric is called observed exposure.
Right.
And to understand why this is such a big deal, you have to look back at how economists historically tried to predict job losses. If you rewind to the early 2000s, there's this massive offshoring panic.
Oh, absolutely. Everyone was terrified.
Right. Economists looked at all the jobs that required sitting at a computer, sending data over an internet connection, and they predicted that a massive chunk of the U.S. white-collar workforce was going to be outsourced overnight.
But that didn't happen.
No. A decade later, we looked at the data, and most of those domestic jobs had actually maintained incredibly healthy employment growth. The economists falsely assumed that just because a job could be done cheaper overseas, it would be done immediately. They ignored all the logistical friction.
And we saw the exact same theoretical panic repeat itself with the initial wave of large language models. Back in 2023, there was a highly publicized foundational paper by researchers like Tina Ilendo.
I remember that one.
Yeah, they created a theoretical exposure model using human annotators and those early GPT models. Their methodology was basically to look at a massive list of tasks and ask, could an AI theoretically complete this task twice as fast without a drop in quality?
And if the answer was yes, boom, highly exposed.
Exactly. The flaw in that methodology is that it conflates intellectual capability with real-world deployment. Just because an AI model has the raw processing power to, say, draft a complex legal brief in 10 seconds.
You mean a corporate law firm is actually willing to let an autonomous agent draft and file that brief without human oversight?
Precisely. So the researchers at Anthropic realized they needed a metric grounded in reality, not theory. They created observed exposure by mashing up 2 massive data sets. First, they took the ONET database.
And for those unfamiliar, ONET is this incredibly dense, comprehensive database maintained by the U.S. Department of Labor.
It's massive.
It doesn't just list jobs. It breaks down about 800 unique occupations into thousands of highly specific, granular daily tasks. So it takes a title like financial analyst and breaks it down into individual actions.
Right.
Things like evaluate financial risks, prepare investment strategies, and assess economic trends.
Right, and then Anthropic took that government taxonomy and crossed it with their own proprietary Anthropic Economic Index. This is where the actual reality check happens.
The telemetry.
Yes. They tracked millions of real-world anonymized interactions with their Claude AI models. But, and this is key, they didn't just count every single prompt. They specifically filtered out casual experimentation.
So no people asking for a pancake recipe or a funny poem.
Exactly. They zeroed in on automated, highly structured, work-related usage. They were looking for first-party API implementations. Situations where the AI is integrated into a company's back-end systems and human intervention is systematically minimized.
Wow.
Yeah, they map those specific real-world enterprise API calls back to the ONET task database to see what human tasks are actively being delegated to the machine right now.
And when you look at that data, It reveals what might be the most important concept for any professional working today. It's the utilization gap.
The gap is huge.
It is a massive chasm between what the AI is intellectually capable of executing and what the corporate infrastructure is actually allowing it to execute. Let me read you the numbers from the report because the disparity is staggering.
Go for it.
Let's look at computer and mathematical occupations. According to the old theoretical models, AI has the raw capability to do 94.3% of the tasks in that sector.
That is near total automation capability.
Right. But the observed exposure, the actual real-world usage happening right now, is only 33%.
The numbers in the administrative sector are equally striking. Office and administrative support roles have a 90% theoretical AI capability coverage. The AI possesses the reasoning to do almost all of that work.
But the actual use.
The observed real-world exposure is hovering at just 34.3%. Business and financial operations sit at 94.3% theoretical capability, but only 28.4% observed exposure.
That's a huge drop-off.
And perhaps the most telling is the legal profession.
Wow.
89% theoretical capability, meaning the AI can comprehend and generate the dense legalese required. Yet the actual observed exposure is a measly 20.4%.
So if the model is smart enough to do 90% of the work, but companies are only letting it do 20% to 30%, there's a massive bottleneck here.
Right.
And that bottleneck clearly isn't the intelligence of the model.
No, the bottleneck is enterprise friction. It is the structural, legal, and architectural reality of the corporate world. There are three major layers of friction keeping that utilization gap wide open right now.
Okay, what's the first one?
The first is massive legal and regulatory constraint. Consider a specific own-it task in the medical field, like authorizing drug refills and providing prescription information to pharmacies.
An advanced LLM could easily do that.
Absolutely. It is intellectually capable of reviewing a patient's chart, understanding the required dosage, checking for drug interactions, and generating the authorization. But if you look at the real-world telemetry, there is virtually zero automated usage for that specific task.
Because of the liability.
Exactly. The regulatory framework of the FDA, HIPAA compliance, and medical malpractice liability laws require a licensed human medical professional to authorize that prescription. The risk of a multi-million-dollar lawsuit prevents the hospital from deploying the technology, regardless of how capable it is.
It's like having a hypercar engine, but you're forced to drive at 50 miles per hour in a school zone because the roads, in this case, our corporate, legal, and IT infrastructures, just aren't built for it yet. The capability is sitting right there, but the operational environment makes it impossible to actually use it.
That is a highly accurate way to visualize the second layer of friction, which is the infrastructure hurdle.
Right.
To actually automate a workflow and realize those productivity gains, the AI cannot just exist in a web browser tab.
You can't just copy-paste your way to enterprise efficiency.
Exactly. It needs to be deeply, natively integrated into a company's legacy systems. We're talking about enterprise resource planning systems, secure proprietary databases, internal software that might have been built 20 years ago.
Yeah, getting a state-of-the-art AI model to securely access and manipulate a massive Oracle database from 2008 without breaking the entire system is an absolute IT nightmare.
It requires an entirely new architecture. This is why you hear so much about the Model Context Protocol, or MCP, right now.
Oh, MCP is everywhere in the developer forums.
Because it's essential. MCP is essentially an open standard designed to act as a universal translator. It allows AI models to securely connect to these disparate data sources in a standardized way. But building out those MCP servers, mapping the data, setting the security permissions, and rigorously testing the integration, that takes enterprise IT departments years to accomplish.
And there's still a third layer of friction, right?
Yes, mandatory human verification. Even in cases where a task is successfully delegated to an AI via an API, corporate compliance currently mandates rigorous human review. They have to ensure accuracy, prevent hallucinations, and maintain brand safety before any output is actually finalized.
So if corporate IT, legal liability, and human review protocols are the only things slowing this down, then anyone sitting behind a desk is basically living on borrowed time.
That's the hard truth.
The gap exists now, but it's not permanent. I mean, as companies hire more developers to build those MCP connections, as liability insurance adjusts, and as companies get more comfortable with AI output, that observed exposure number, that 33%, is going right up. It's going to ruthlessly climb toward that 94% theoretical capability.
The legal and IT roads are being paved as we speak. The window to adapt is open right now, but it is actively closing. And the data from Anthropic provides a very clear picture of who is sitting directly in the crosshairs as that utilization gap shrinks.
Okay, let's get right into the hit list. We promised you the bottom line on which specific job roles face the highest risk of AI displacement based on this new telemetry. I'm going to rapid fire the top 5 exposed occupations straight from the Anthropic data.
Let's hear them.
At the absolute apex, sitting at 74.5% observed exposure, are computer programmers. The data shows their primary automated task is writing, updating, and maintaining software programs. Number 2 on the list, customer service representatives at 70.1% exposure. Number 3, data entry keyers at 67.1%. Number 4, medical record specialists at 66.7%. And rounding out the top 5 are market research analysts and marketing specialists at 64.8%.
Notice the common denominator across all of those roles. This technological disruption is highly targeted. It is aiming almost exclusively at screen-based, language-heavy, highly repeatable cognitive work. It is targeting the processing, summarizing, and generation of digital information.
But let's look at the other end of the spectrum. The report highlights that roughly 30% of the workforce has absolute zero exposure to this specific AI disruption.
Zero.
We are talking about jobs like line cooks, motorcycle mechanics, lifeguards, construction workers, agricultural equipment operators. Why is a highly complex job like tearing down and rebuilding a motorcycle engine completely safe, while writing a complex Python script is at 74% exposure?
It comes down to a principle known in computer science as Moravec's paradox. Back in the 1980s, researchers like Hans Moravec and Marvin Minsky noticed something really counterintuitive about artificial intelligence.
Oh, that.
They realized that high-level reasoning, the abstract cognitive logic required to play chess, analyze financial data, or write code, actually requires very little computational power for a machine. But low-level sensorimotor skills...
Like physical dexterity?
Exactly. The physical dexterity required to walk up a flight of stairs, prune a rosebush, or manipulate the delicate components of an engine, those require enormous, currently insurmountable computational and robotic resources.
So from an evolutionary standpoint, the things that took humans billions of years to evolve, like bipedal movement, spatial awareness, fine motor control, are incredibly hard to replicate in a machine.
Right.
But the things we only developed in the last few thousand years, like abstract math, formal logic, written language, are actually quite easy for a computer to mimic.
What's fascinating here is how this dynamic creates what is arguably the most profound macroeconomic finding in the entire Anthropic report. We call it the demographic paradox.
Because if you look at the entire history of technological disruption, whether it was the mechanization of agriculture, the Industrial Revolution, or robotic arms on assembly lines, the disruption almost universally gutted blue-collar, lower-educated, lower-income workers.
But AI is executing a complete socioeconomic reversal. The researchers cross-referenced their observed exposure data with the current population survey, and the demographics of the most vulnerable workers are the exact opposite of historical norms.
Wild.
Workers in the highest exposure quartile are 15.5 percentage points more likely to be female than the unexposed group. They trend significantly older. They are 10.6 percentage points more likely to be white and nearly twice as likely to be Asian.
But the most striking disparity lies in education and income levels. Let's dig into those numbers because they completely shatter the traditional narrative of who needs to worry about automation.
They really do. People with graduate degrees, master's degrees, doctorates, professional degrees make up just 4.5% of the completely unexposed group. However, in the most highly exposed group, 17.4% hold graduate degrees.
That is almost a fourfold difference.
And economically, the highly exposed group earns an average of 47% more. We're talking $32.69 an hour compared to $22.23 an hour for the unexposed group.
The bottom line here is that the primary target of this technological disruption is the highly educated, high-earning, white-collar knowledge worker. If you're sitting in a climate-controlled office drinking a latte and manipulating spreadsheets or text documents, you are the prime target for corporate restructuring.
The reason why is simple mathematics.
Right. Automating the daily cognitive tasks of a data analyst making $120,000 a year yields a massive immediate return on investment for a corporation.
Yeah.
It is infinitely cheaper to deploy a $30 a month API software pipeline than it is to spend 10 years and $50 million trying to engineer a physical robot that can reliably replace a $40,000 a year line cook without burning the restaurant down.
Exactly. The ROI just isn't there for the physical tasks yet.
But wait, let me play devil's advocate here, because we have to talk about the Jevons paradox. Going back to the 19th century, William Stanley Jevons noticed that when the steam engine became vastly more efficient, we didn't use less coal.
No, we use way more.
Right, we used way more coal because energy became so cheap that we found a million new ways to use it. If AI makes software engineering or data analysis incredibly cheap and lightning fast, won't companies just demand 1,000 times more software and 1,000 times more data analysis?
That's a very common argument.
Doesn't making a cognitive resource cheaper just exponentially increase the overall demand for it, effectively keeping all these exposed workers employed, just doing vastly more stuff?
The application of the Jevons paradox is central to the debate among labor economists right now. You are entirely correct that making software development cheaper will likely increase the overall appetite for software. We will see custom software built for hyper-niche use cases that were previously too expensive to justify.
So the jobs don't disappear entirely.
Right, we may not see the total number of employed software engineers drop to zero. However, the Jevons paradox changes the nature and the expectations of that employment.
The bar for productivity gets raised to a level a traditional human can't meet on their own.
Exactly. A corporation will absolutely demand vastly more software, but they will realize they do not need a team of 15 mid-level engineers writing basic foundational code to achieve it. Instead, they will require a team of 3 highly skilled senior engineers who are managing automated AI systems that can output the volume of 50 traditional engineers. The expectation of what a single human worker must produce in an 8-hour day is fundamentally shifting.
Which brings us to the most practical part of this deep dive. If productivity expectations are skyrocketing, how are professionals actually surviving this shift? We promise to give you 3 concrete examples of how workers are using AI to increase their output today, pulled straight from the Anthropic data and current industry practices.
Let's look at example number 1, software developers.
We established they have the highest observed exposure at 74.5%. How does a developer actually use this technology to survive the productivity squeeze?
They are surviving by fundamentally altering the architecture of their workflow. A modern developer isn't just opening ChatGPT in a side window and asking it to write a Python script. They are deeply integrating tools like Cursor AI directly into their development environment. And crucially, they are moving beyond simple autocomplete functions and deploying autonomous background agents.
What does that actually look like in practice? Give me the day-to-day.
Think about the continuous integration and continuous deployment pipeline, the CI/CD pipeline. When a developer finishes writing a module and commits that new code to the central repository, they have AI agents that are triggered automatically in the background,
Without the human asking them to.
without any human prompting at all. These agents instantly review the committed code, scan it for security vulnerabilities against known databases, analyze it for logical errors, format it to meet the company's specific style guidelines, and even suggest structural optimizations. The AI is autonomously handling the boilerplate creation, the initial bug hunting, and the quality assurance protocols.
Okay, example number 2, customer service. This sector is sitting at 70.1% exposure. How is productivity shifting when dealing directly with consumers?
The shift in customer service is entirely about semantic routing and intercepting massive volumes of routine interactions before they ever reach a human. Organizations are aggressively implementing first-party API pipelines deeply integrated into platforms like Zendesk or Salesforce.
So when I email about a refund,
Right. When a customer sends an email or opens a chat regarding a delayed shipment or a password reset, the AI doesn't just suggest a response to a human agent. The AI natively reads the intent of the message, accesses the customer's account data in the backend database, processes the routine refund or triggers the password reset protocol, and responds to the customer, closing the ticket instantly.
it is bypassing Tier 1 support entirely. The human agent never even sees the interaction.
The human only sees the anomalies. And that brings us to example number 3, medical and data entry. Medical record specialists are at 66.7% exposure.
Now, we discussed earlier how regulatory liability prevents the AI from making actual clinical decisions or authorizing prescriptions. So where does the productivity gain come from in a highly regulated environment?
The immense productivity gain lies in the translation of unstructured data into highly structured data sets. The healthcare industry is drowning in messy, unstructured data.
Oh, I can imagine.
Imagine a patient file that contains digitized, handwritten physician notes from a specialist, a PDF of lab results from an external clinic, and historical medical records from a different hospital system entirely. Historically, a human specialist had to read through all of that, manually abstract the relevant patient history, identify the correct billing codes, like the incredibly complex ICD-10 codes, and manually type them into the hospital's central database.
And now the AI acts as the universal translator for all that mess.
Precisely. The medical record specialist utilizes an LLM to ingest all of those disparate, unstructured source documents simultaneously. The AI instantly reads the handwritten notes, cross-references the external lab results, abstracts the relevant risk factors, and formats it perfectly into the standardized SQL database or FHIR standard required by the hospital.
That's incredible.
The human is no longer hunting for data. They are simply reviewing the AI's structured output for accuracy. This effectively doubles or even triples the daily output capacity of the human specialist.
When you look at all three of these examples, the background coding agents, the automated customer service routing, the medical data structuring, the bottom line productivity impact is identical across the board.
It's about removing friction.
Exactly. The AI is removing the friction of initial creation and initial data sorting. It writes the first draft of the code, it handles the initial customer grievance, it sorts the initial chaotic data. But if the AI is doing all of the foundational creating, what exactly is the human's job now?
This is the pivotal evolutionary question for the modern workforce. To remain competitive, you must adapt your skill set to a completely new paradigm. The era of the human being valued primarily as a creator of raw content or foundational logic is ending.
It's just over.
It is. The new economy requires the human to evolve into an editor and a manager.
Let's apply that evolution to the specific roles we just analyzed. How does a software developer transition from a creator to a manager?
A developer's core market value is no longer tied to their rote memorization of coding syntax, or their willingness to spend 6 hours writing standard boilerplate functions that have been written a million times before.
Right.
Their value is now their higher-order ability to act as an agent handler or a systems architect. They must understand the overarching architecture of the software on a macro level. Their daily job involves defining the logical parameters for multiple AI agents, deploying those agents in parallel to solve different components of a problem, and then critically evaluating the code those agents generate.
I have to make sure it all actually works together.
Exactly. They have to ensure that the AI's output integrates safely, securely, and efficiently into the wider legacy ecosystem. They're essentially managing a team of digital juniors.
And what about the customer service sector? If the AI is seamlessly intercepting and resolving all the Tier 1 tickets, the password resets, the basic shipping updates, what are the remaining human representatives doing all day?
They are upskilling into entirely new, highly specialized hybrid roles. The surviving customer experience representatives are transitioning into roles like AI trainers.
AI trainers.
Yes. They spend their day reviewing the chat logs of the AI agents, identifying areas where the AI misunderstood customer intent, and actively tweaking the system prompts and semantic routing parameters to improve the model's future accuracy. They are becoming automation supervisors.
But there are also interactions an AI simply cannot handle, regardless of how well it is trained.
Which is why the most critical human role in CX is becoming the escalation specialist. They are deployed specifically to handle the complex, high-stakes, deeply emotional negotiations where AI routinely fails.
I can think of a few times I've been that angry customer.
We all have. Consider a scenario where a bridal shop's logistics system fails and a wedding dress is lost in transit 3 days before the ceremony. An irate, panicked customer does not want to speak to an AI that politely offers a standard 15% discount code and regurgitates a tracking number.
No, that would make it 10 times worse.
An AI possesses zero genuine empathy, and it cannot navigate the complex, emotionally volatile problem-solving required to salvage that customer relationship. The escalation specialist steps in, utilizing deep emotional intelligence and discretionary authority to resolve the crisis. That emotional labor is where the human premium lies.
And the broader industry data completely supports this transition from low-level creator to high-level editor and specialist. The sources we are looking at highlight some incredible statistics regarding corporate restructuring in the customer experience sector.
Yeah, the reports indicate that over 80% of organizations expect to permanently reduce their base customer experience headcount over the next 18 months. The era of the massive 1,000-person call center handling basic inquiries is closing.
But they aren't just firing everyone.
No, nearly as many of those organizations plan to transition a significant portion of their remaining smaller staff into these specialized higher-level roles. And the Bureau of Labor Statistics is already noting a massive 14% surge in customer service productivity, driven specifically by these exact hybrid human AI models. Corporations are getting vastly more work done and resolving tickets faster with a significantly smaller, more highly skilled workforce.
Here's where it gets really interesting, though. If everyone would have to evolve into a manager of AI, if the AI is doing all the boilerplate code and the AI is intercepting all the Tier 1 customer support tickets and doing all the basic data sorting, what happens to the entry-level folks who just need to learn the ropes? Where does the 22-year-old college grad go to learn how to be a senior architect or an escalation specialist?
You have just identified the starkest, most alarming macroeconomic finding buried within this entire dataset.
The impending destruction of the entry-level pipeline.
Exactly. And if we connect this to the bigger picture, it brings us directly into the contrast between current labor market data and long-term economic projections.
Let's start with the current data because it is confusing a lot of people right now. Since the widespread mainstream release of ChatGPT in late 2022, we have all been bracing for impact. We've been waiting for the other shoe to drop, expecting massive, headline-grabbing unemployment numbers in the white-collar sector.
But that apocalypse hasn't materialized yet, has it?
Not at all.
Right. The Anthropic researchers utilized a statistical method known as a difference in differences analysis on the current unemployment data.
Let me make sure I'm understanding this differences thing. Is it basically like a clinical trial? Like where you take the group of highly exposed workers as the treatment group and compare their employment trajectory against the completely unexposed workers like the line cooks and mechanics as a control group to see if the AI is actually causing a divergence in their employment rates?
That is an excellent way to frame it. You establish a baseline trend for both groups prior to the widespread adoption of AI in 2022, and then you track them forward to see if the exposed group's unemployment suddenly spikes relative to the control group.
And what did they find?
The surprising result is that there is absolutely no systematic, widespread spike in unemployment for highly exposed workers.
So despite all the capabilities we just discussed, there are no mass layoffs for the highly exposed groups.
Not on a macroeconomic scale. If you look back at the Great Recession of 2007 to 2009, following the collapse of Lehman Brothers and the housing market, unemployment rates practically doubled across the board in a matter of months.
Jumping from roughly 5% to 10%.
Right. That is what a severe, sudden economic shock looks like in the data. We are simply not seeing that kind of sudden cliff in the data for AI-exposed professions. The mass layoffs are not materializing in the aggregate numbers.
But the pain is definitely being felt somewhere. You talk to anyone trying to get a job in tech, marketing, or administration right now, it is a brutal market.
Right.
If it isn't mass layoffs of existing staff, what exactly is happening?
We are experiencing what labor economists are beginning to call a ghost recession. And the pain of this recession is almost entirely targeted at youth hiring and new entrants to the workforce.
New grads.
Exactly. When the researchers drilled down into the panel data, specifically tracking workers aged 22 to 25 who are actively trying to enter the workforce for the first time, they found a severe contraction. They documented a 14% drop in the job finding rate for that specific age group, attempting to enter highly exposed occupations, compared to the baseline hiring rates in 2022.
A 14% drop in hiring for young workers. Think about the 22-year-old marketing grad right now. In 2019, that grad would get hired by an agency specifically to write the first drafts of social media ad copy or summarize market research reports.
They'd do the grunt work.
Right. They would do the grunt work for 5 years, learn the industry, understand the client's voice, and eventually get promoted to an art director or a senior strategist. But if an enterprise AI model can instantly generate 50 variations of ad copy in 3 seconds, the agency doesn't need to hire that 22-year-old anymore.
And that is the exact mechanism of the ghost recession. Companies are aggressively automating the boilerplate tasks, the Tier 1 support, the basic data entry, and the initial copywriting. Historically, performing those exact repetitive tasks served as the essential training ground for junior employees. It's how you learn the mechanics of the business.
And now that's gone.
By automating those foundational tasks, corporations are quietly, seamlessly closing the door on new entrants. They don't have to announce massive layoffs, and they don't have to fire their experienced senior staff. The 14% drop in youth hiring doesn't show up in the headline aggregate unemployment numbers because these 22-year-olds are simply never hired in the first place.
The jobs vanish before they are ever posted.
Precisely. Those young workers are forced to return to graduate school, take jobs in unexposed sectors like retail or the physical trades, or they simply drop out of the labor force entirely.
It's a silent contraction. Now, how does this immediate youth hiring freeze align with the government's long-term projections for the economy?
The current data actually aligns very closely with the long-term projections issued by the Bureau of Labor Statistics. The BLS does not project a sudden employment cliff or a mass extinction of jobs. Instead, they project a slow, steady deflation of demand.
Deflation of demand.
Right. Their current models estimate that for every 10 percentage point increase in AI task coverage for a given occupation, that occupation's projected 10-year growth rate drops by 0.6 percentage points.
So if a job has 50% AI task coverage, its growth rate over the next decade drops by 3 full percentage points.
Exactly. Over the next decade through 2034, these highly exposed professions will not disappear overnight, but they will grow significantly slower than the rest of the economy. It is a slow-motion structural shift, a gradual tightening of the labor pool rather than a sudden apocalypse.
But to be fair to the entire macroeconomic picture, we have to address the critiques of this Anthropic data. Because not everyone in the economic community agrees that the coast is clear regarding mass layoffs. There's a major critique of this report, specifically championed by digital strategy experts like Hamilton Mann, which is commonly referred to as the keyhole problem.
Yes, the keyhole problem.
Let's break down this methodological debate because it's crucial for understanding the potential blind spots in the data. Are economists potentially missing a much broader avalanche of job displacement?
The keyhole problem is a highly valid, critical piece of context. The critique centers on the fact that the data powering Anthropic's observed exposure metric comes almost exclusively from their own proprietary telemetry, specifically Anthropic's Claude AI API traffic.
So they only see what passes through their own servers.
Exactly. Critics like Hamilton Mann argue that evaluating the entire global labor market based solely on Claude API calls is like trying to view a sprawling landscape through a tiny keyhole. Anthropic's data, by definition, completely ignores the massive volume of automation occurring on competing platforms.
Like Microsoft.
Right. It doesn't track Microsoft Copilot deeply embedded in Office 365. It doesn't track OpenAI's enterprise models. It doesn't track Google Gemini. And most importantly, it ignores the countless custom open source AI models that Fortune 500 companies like JP Morgan or Walmart are running internally on their own proprietary servers.
So the argument is that if Anthropic is only seeing 33% observed exposure through their specific keyhole, the actual total observed exposure across the entire economy might already be at 50% or 60% if we could see all the data from all the tech giants combined.
That is the core of the keyhole critique. Furthermore, data scientists point out that relying heavily on API traffic can be inherently misleading. Millions of API calls hitting an Anthropic server might just be a corporate development team running automated load tests in a secure sandbox environment to see if a concept works.
It's just testing.
Yeah, it does not necessarily prove that a fully functional AI agent has been permanently deployed into production and actively replaced a human worker's daily tasks.
But the defenders of the Anthropic report argue that even with those blind spots, this is still the best map we have, right?
Yes, defenders of the methodology argue that while it is a keyhole, it is a massive, highly representative keyhole. Anthropic's data provides the most robust, granular proxy we currently possess for enterprise adoption. It is a massive sample size of real-world corporate behavior.
And the other data backs it up.
Exactly. The secondary trends identified in the report, specifically the 14% drop in youth hiring and the ghost recession dynamics, are being corroborated by independent third-party payroll data from massive processors like ADP. So while the exact percentage points of observed exposure might shift slightly if we had perfect universal data from every tech company on Earth, the underlying structural trends identified in the report are very likely real, accurate, and actively reshaping the labor market as we speak.
All right, we have covered a massive amount of dense economic theory, technological infrastructure, and labor data today. It is time to fulfill our promise to you, the listener. We promised you the absolute bottom line, distilling all of this complex intelligence into actionable knowledge. Here are the 3 most important takeaways from this deep dive that you need to understand right now.
Takeaway number 1.
Yes, takeaway number 1. The demographic target of AI is a complete reversal of the historical norm. This technology is not targeting blue-collar physical labor. The crosshairs are locked directly on highly educated, high-earning, white-collar professionals. If you sit to screen, analyze information, and generate digital content, you are the prime target for corporate automation, and you need to prepare accordingly.
And takeaway number 2?
Takeaway number 2. The immediate economic threat is not mass layoffs. You probably aren't going to walk in your office tomorrow and find a physical robot or an algorithm sitting at your desk. The real economic shock is a ghost recession, marked by a severe 14% drop in entry-level youth hiring. The foundational boilerplate tasks are being aggressively automated, quietly closing the door on the next generation of workers without inflating the headline unemployment numbers.
Which brings us to takeaway number 3.
Takeaway number 3. To survive this structural shift, you must fundamentally adapt your skill set today. The era of the human as a raw creator is ending. You must transition your value into becoming an editor, a systems architect, and an agent handler who expertly oversees, directs, and critically evaluates automated AI pipelines.
And looking at the totality of this data, it leaves us with a profound, lingering question to mull over. If corporate America successfully automates all the junior-level boilerplate tasks, the exact tasks that have traditionally served as the vital training ground for young professionals to learn their industry, how will the labor market ever train the senior architects, the complex problem solvers, and the high-level strategists we will desperately need a decade from now? By maximizing short-term productivity today, we might be systematically burning our bridge to future human expertise.
That is a deeply concerning thought, especially for anyone looking at the long-term health of our workforce, and is definitely a trend we will be tracking closely. Thank you for joining us for this deep dive. If you want to stay ahead of the curve on all of these rapid technological shifts and understand how they impact your bottom line, remind yourself to check out the Tech News TLDR YouTube channel for our daily video updates. We break down the headlines every single day so you don't get left behind. We'll see you next time.